Hey guys, Mr. Gucci here, and as promised, I am making a help video for the 14.3 acids and bases worksheet. Now, really, I think the only part that you probably need assistance on in this worksheet, let me pull up the right Google Classroom here. Okay, yeah, sorry, found it. Here we go. So the only thing that I think you really need help with in this video, that's not just right off of the notes, is this portion right here where you are doing a bit of predicting and balancing these reactions. Now, these are essentially double replacement reactions, just like we worked on in Unit 8, which happens to be the first unit you reviewed for the final. Okay, so this is going to be really valuable, not just for this unit, but for helping you get ready for the final. So I am going to do a few of these type of problems on a separate sheet. Not these exact ones, mind you, but a few different ones. Here we go. Okay, so let's see how we would do a double replacement reaction. So, double replacement reaction is two ionic compounds. And remember, we can treat the acid as if it were an ionic compound. Hydrogen has a +1 charge. Sulfur has a 2- charge. Potassium has a 1+ charge, and hydroxide, OH, has a 1- charge. All right, now you might be asking me, Mr. Gucci, how do you remember these charges? Well, I remember them because I memorized them. As for you guys, what I request that you do, what I recommend you do is go back to Unit 8 and pull up the monoatomic ion sheets. Pull up the polyatomic ion sheet. In fact, I made this easier for you. I just attached them to your homework assignment. Look, here they are, monoatomic, polyatomic ions. So I go to this and I see hydrogen is +1. There's hydrogen +1. Sulfur is 2-. Okay, there you go. Magnesium, Mg, is 2+. And hydroxide, a polyatomic ion, is 1-. All right, so I can fill that. Sorry, potassium is 1+. Okay, so a double replacement reaction, what we have to do is we have to combine the positive ion from one compound with the negative ion from another compound. So this positive H+ is going to combine with that negative OH-. All right, what do we make? Hydrogen is 1+, hydroxide is 1-. You get a +1 and a 1- together, they will cancel out and you will form HOH. All right, remember the crisscross method. You got 1 and 1. Also, you could just write that as H2O. Remember, in these neutralization reactions, one of the products is always H2O. Okay, the tricky one is, what is the other thing that you make? Well, let's see here. You've got potassium, which is 1+, combining with sulfur, which is 2-. So potassium is 1+, sulfur is 2-. All right, you crisscross, and you get that the other product is K2S, potassium sulfide. Okay, so there you go. Those are the products. Now what you need to do is you need to balance it. Okay, so let's balance it. Now, when you balance it with the H2O, that can be a little bit tricky. Sometimes it's actually easier just to turn this back into HOH, a hydrogen and a hydroxide. Let's do that, and then now let's try and balance it. Let's use a nice bright balancing color. Okay, we've got 2 hydrogens and only 1 hydrogen here, so we're going to put a 2 in front. Now we've got 2 hydrogens, okay? We've got 1 sulfur and 1 sulfur. Great. We have got 1 potassium and 2 potassium, so we're going to put a 2 in front right here. Okay? And now we have 2 OHs and we have 2 OHs. So this is the balanced equation right here. 1, 2, 2, 1. Okay? Maybe that went a little bit fast. Let's do another one. Okay, so next up we got HNO3, nitric acid, and calcium hydroxide, CaOH2. So let's start by identifying the charges, all right? Hydrogen is still and always 1+. NO3, nitrate, let's look it up. Nitrate, NO3 with a 1- charge, all right? NO3 with a 1- charge. All right, then we got calcium and hydroxide. Hydroxide is still 1-. It's the same substance, so it's going to be 1-. And calcium has what charge? Let's take a look. Calcium is a monoatomic ion. Calcium is 2+. Calcium is 2+. All right, so calcium is 2+. Here we go. So now we're going to combine these to make 2 new ionic compounds. Well, in a reaction like this, a neutralization reaction, we know that one of the things we're going to get is the hydrogen is going to combine with the hydroxide to form water, H2O or HOH, depending on how you want to write it. Okay? Remember, hydrogen is 1 plus. Hydroxide is 1 minus. So because we got a 1 plus and a 1 minus, their charges cancel, and you just put them both together. One of each. All right? Next up, we got to combine the calcium, which is 2 plus, with the nitrate, which is 1 minus. So calcium, 2 plus, nitrate, 1 minus. Now remember, nitrate is NO3. That is a single nitrate, okay? So in order to crisscross, we are going to have 1 calcium and 2 nitrates. Remember what this looks like. 1 calcium is Ca, and 2 nitrates is NO3 in parentheses, 2. All right, so the formula for calcium nitrate is 1 calcium, 2 nitrates. A little room here for balancing. And now we have to balance this. Okay, now we've got to balance. So let's see. We've got 1 hydrogen, and I'm going to rewrite this to make it easier to work with. Remember, this water came from a hydrogen and a hydroxide. So if we think of it as an H and an OH, it'll make it easier to balance. So we got 1 hydrogen here, 1 hydrogen here. Great. We've got 1 nitrate here, but we've got 2 nitrates here. So we got to put a 2 in front. Okay? Uh-oh, now that we put a 2 in front, we've got 2 hydrogens, so we got to put a 2 in front there to balance that out. All right? And so now we have a calcium, 2 hydroxides, and 2 hydroxides. So this is balanced. It balances as 2, 1, 2, 1. All right. Let's take a look at the last one here. All right. We've got H2CO3 and aluminum hydroxide, AlOH3. All right, let's get these charges in here first. Hydrogen, of course, is 1 plus. Hydroxide is, of course, 1 minus. All right, what about carbonate, CO3? What's the charge of a carbonate? I'm going to go to the polyatomic ion list, and I'm going to see carbonate is CO3 with a 2 minus charge. So this guy is 2 minus. By the way, guys, so long as you know what the charge of hydrogen and hydroxide are, you don't actually need to look up the other guys. You see here that it takes 2 hydrogens to cancel the charge of a single carbonate. So the carbonate has to be 2 minus. Otherwise, there's no other way for those 2 positive hydrogens to cancel it out. We also see here that it takes 3 hydroxides, each minus 1, to cancel the charge of a single aluminum. All right, so that means that aluminum has to have a 3 plus charge. And if you forget as well, then you can just go to the monoatomic ions and see aluminum 3 plus. Aluminum is 3 plus. Okay, so now let's combine them to make 2 new substances. Well, first of all, the easy one. Hydrogen is 1 plus. It's going to combine with hydroxide, which is 1 minus. One of the products is going to be water, H2O, or also written as HOH. Both of these represent water. Okay? And the other substance we produce is carbonate, which is 2 minus, and aluminum, which is 3 plus. So let's see here. Aluminum, 3 plus. Carbonate, which is 2 minus, you crisscross, and you get 2 aluminums and 3 carbonates. And remember, this is what 3 carbonates looks like. You got to have 1 carbonate, CO3 in parentheses, and then a 3 outside the parentheses. So Al2, CO3, 3. Okay, and now we balance. Okay, now we balance this. Let's take a look. Well, we've got ourselves, let's choose a new balancing color. Okay, we've got ourselves 2 hydrogens and only 1 hydrogen here, so I'm going to put a 2 in front. Okay, we have only 1 carbonate, CO3 is 1, but we've got 3 carbonates over here, so we got to put a 3 in front. But now that makes 6 hydrogens over on this side, and so we got to put a 6 right here to get the hydrogens to balance. All right, we've got 1 aluminum here and 2 aluminums there. So we got to put a 2 in front to get the aluminums to balance out. All right, that gives us 2 aluminums right here. And it gives us 2 times 3, 6 hydroxides. And oh, look, we happen to have 6 hydroxides on this side as well. So there you go. This is the balanced equation. 3, 2, 6, 1. Remember, you can also leave the ones blank. It's implied. If there's no number in front or behind, it's a 1. All right, so there you go. There is the third one right there. Okay, so remember, these double replacement reactions are 2 steps. First, you got to figure out what the products are going to be, and then you need to balance it. All right, I hope this helped, guys. Thank you very much. Have a great day.